Imagine a world without genetic diseases. Picture crops resistant to pests and diseases, thriving in harsh climates. This is the promise of CRISPR, transforming medicine and agriculture. CRISPR lets us rewrite the code of life, offering opportunities to cure diseases and improve food security. It's a tool of immense potential, but it raises profound ethical questions. CRISPR has ignited the imaginations of scientists and the public alike. It's a technology moving at breakneck speed, with new discoveries emerging all the time. In medicine, CRISPR holds the potential to cure genetic diseases like cystic fibrosis and sickle cell anemia. It could also lead to new treatments for cancer and other complex diseases. In agriculture, CRISPR is developing crops resistant to pests and diseases. This could help increase crop yields and make agriculture more sustainable. The potential of CRISPR is vast, but so are the ethical considerations.
CRISPR stands for clustered regularly, interspaced short palindromic repeats. Think of CRISPR as molecular scissors that cut DNA. Guided by RNA, these scissors target specific DNA sequences. Scientists design RNA to match the target DNA. The RNA guides CRISPR to the precise location. The scissors cut the DNA and the cell repairs it. This allows scientists to edit genes precisely. CRISPR is faster, cheaper, and more accurate. It opens up new possibilities for gene research and treatments.
For decades, scientists have dreamed of curing genetic diseases by correcting the faulty genes that cause them. CRISPR is making this dream a reality. With its ability to precisely target and edit genes, CRISPR has the potential to revolutionize the treatment of genetic diseases. Imagine a future where children born with cystic fibrosis could be cured with a single treatment, where sickle cell anemia, a debilitating blood disorder, could be eradicated, where Huntington's disease, a devastating neurological disorder, would no longer haunt families. CRISPR offers hope for millions of people around the world who are living with genetic diseases. Clinical trials are already underway to test the safety and efficacy of CRISPR-based therapies for a range of genetic diseases. While it's still early days, the initial results are promising.
In one groundbreaking trial, researchers used CRISPR to successfully treat a patient with sickle cell anemia. The patient, who had previously required regular blood transfusions, is now free of the disease.
The implications of CRISPR go beyond treating inherited diseases. Scientists are also exploring its use in fighting cancer, developing new antiviral therapies, and even engineering organs for transplantation. In cancer, CRISPR could be used to enhance the immune system's ability to recognize and destroy cancer cells. Researchers are developing CRISPR-based therapies that would essentially reprogram a patient's immune cells to target and kill cancer cells. CRISPR also holds promise for developing new antiviral therapies. Scientists are exploring its use in targeting and destroying the genetic material of viruses, including HIV and hepatitis C. The potential applications of CRISPR in medicine are vast and rapidly expanding. As scientists continue to explore its capabilities, we can expect to see even more groundbreaking treatments emerge in the years to come.
CRISPR is not just revolutionizing medicine, it's also transforming agriculture.
By editing the genes of crops, scientists can enhance their nutritional value, increase their yield, and make them resistant to pests, diseases, and herbicides.
Imagine fields of wheat that are immune to fungal infections, or rice that is fortified with essential vitamins. CRISPR is making these possibilities a reality.
By editing the genes of crops, scientists can enhance their nutritional content, making them more nutritious and beneficial for human health.
CRISPR is also being used to develop crops that are resistant to pests and diseases. This could help to reduce the reliance on pesticides, which can have harmful effects on the environment and human health.
For example, scientists have used CRISPR to develop tomatoes that are resistant to a common fungal disease and potatoes that are less susceptible to blight. These are just a few examples of how CRISPR is being used to improve crops.
As scientists continue to explore its potential, we can expect to see even more innovative applications emerge in the years to come.
The world's population is growing, and with it, the demand for food. CRISPR has the potential to play a critical role in ensuring food security for a growing planet. By increasing crop yields, reducing food waste, and making crops more resilient to climate change, CRISPR could help to feed billions of people. CRISPR can be used to develop crops that are more tolerant to drought, salinity, and other environmental stresses. This is particularly important in the face of climate change, which is expected to make it more difficult to grow crops in many parts of the world. For example, scientists have used CRISPR to develop rice that is more tolerant to flooding, a major problem in many rice-growing regions. CRISPR is a powerful tool that can be used to address some of the world's most pressing food security challenges. By harnessing the power of gene editing, we can create a more sustainable and equitable food system for all.
The power of CRISPR to edit the code of life raises profound ethical questions. While the potential benefits of CRISPR are enormous, so too are the potential risks. It's crucial that we proceed with caution, carefully considering the ethical implications of this technology before it's widely deployed. One of the most pressing ethical concerns is the potential for unintended consequences. CRISPR is a powerful tool, but it's not perfect. There is always the risk that editing one gene could have unforeseen consequences for other genes or for the organism as a whole. Another concern is the potential for CRISPR to be used for non-therapeutic purposes, such as enhancing human capabilities. For example, CRISPR could potentially be used to enhance muscle mass, intelligence, or even physical appearance. Such applications raise serious ethical concerns about designer babies and genetic inequality.
Section 8. Weighing the benefits and risks, responsible use of CRISPR. The ethical debate surrounding CRISPR is complex, and honestly, there are no easy answers. It's essential that we have open and transparent discussions about the potential benefits and risks of this technology. We need to establish clear ethical guidelines and regulations for the use of CRISPR, ensuring that it's used responsibly and for the benefit of all. One approach is to adopt a precautionary principle, which dictates that we should err on the side of caution when dealing with new technologies with potentially irreversible consequences. This means proceeding slowly and carefully with CRISPR research, conducting thorough risk assessments, and engaging in open and transparent public dialogue. Another important aspect of responsible CRISPR use is ensuring equitable access to its benefits. CRISPR has the potential to revolutionize medicine and agriculture, but only if its benefits are shared equitably. We need to ensure that CRISPR-based therapies are affordable and accessible to all who need them, regardless of their income or geographic location. Section 9. CRISPR and the future. A world of possibilities. CRISPR is a game changer, a technology with the potential to reshape our world in profound ways. It's a tool that could help us cure diseases, feed the planet, and even reshape the future of our species. But it's also a tool that must be used responsibly and with great care. The future of CRISPR is full of possibilities, but it's up to us to shape that future. We need to approach this technology with a sense of responsibility, humility, and a commitment to using it for the greater good. CRISPR has the potential to usher in a new era of medicine, one in which genetic diseases are a thing of the past. It could also transform agriculture, making it more sustainable and equitable. However, we must proceed with caution, carefully considering the ethical implications of this powerful technology. We need to establish clear ethical guidelines and regulations to ensure that CRISPR is used responsibly and for the benefit of all. Section 10. The importance of public dialogue. Public dialogue is crucial to ensuring the responsible development and use of CRISPR. We need to have open and honest conversations about the potential benefits and risks of this technology. We need to engage with the public, addressing their concerns and ensuring that they have a voice in shaping the future of CRISPR. Scientists have a responsibility to communicate their research to the public in a clear and understandable way. We need to explain the science of CRISPR, its potential benefits, and its potential risks. We also need to listen to the public's concerns and engage in a dialogue about the ethical implications of this technology. Policymakers also have a critical role to play. They need to be informed about the science of CRISPR and its potential implications. They need to develop sound policies that foster innovation while also addressing the ethical concerns surrounding CRISPR. CRISPR's legacy. CRISPR is a powerful tool with the potential to revolutionize medicine, agriculture, and our understanding of life itself. It fills us with both hope and trepidation. Hope for the diseases it could cure and the hunger it could alleviate. Trepidation for the unintended consequences and ethical dilemmas. We must proceed with both audacity and humility. Audacity to explore CRISPR's potential and dream of a healthier future. Humility to acknowledge our limits and ensure wise use. The legacy of CRISPR is yet to be written. It's a story we must write together.
Subscribe for more.